thank you so much to be here. It's challenging and also so inspiring. So let me start with my presentation. First of all, I'm speaking to you from Brazil. Right now it's spring here. It's 5 p.m. and outside is 32 degrees. This is me 2 hours ago preparing myself to talk to you right now. And let me present myself. My name is Regina Ruschel. I am a senior contributing professor at the University of Campinas in Brazil. And Campinas stays 100 kilometers from São Paulo. I'm a civil engineer and I have a PhD in computer engineering. Maybe that's why as goal I have to educate, since I've been in academia for 30 years, but especially to support digital transformation, architecture, engineering, and construction. That's why I need always to collaborate and to build or be in an interdisciplinary space. As for myself, I'm a very frank person, systematic, sometimes shy, sometimes not, but always in outside of my comfort zone, like I feel right now, because of learning or because of challenging myself. Frustrations, well, my native language is not English, it's Portuguese. So you see sometimes that I don't express myself well. And of course, social distancing right now is frustration for all. We've been in this situation since March here in Brazil. And let's hope for the best in 2021 and the best for all who are working and cannot be in social distancing right now. Another frustration, I think, which is the theme of my talk here today, is that architectural engineering and construction science is not easily transferred to industry. So I'm going to share with you my everyday approach to work, which is the research process. I have noticed in the presentation of some teams that you all start like me with a problem. So to do science is to be in a discovery journey, which needs planning. Planning is required. That's why I put this image here. So to be in the top of a mountain looking a view like this, planning is required. The shoes, the load you're going to carry, the trajectory you're going to do, so you can take the most out of it. So in research, we always start with a controversial subject not yet answered and with questions about it. You put all the questions out. Where, what, how, when, how much, and you put all these questions on this problem, and you narrow down to the ones that have relation to each other and that you see that you have the competence to tackle and that you have the interest to go about. After that, you draw an objective, an action of familiarization, of characterization, of frequency determination of the problem, of causality, why, and of prescriptive, an action of a solution. Most of you right now are in this point, né? Have to draw, have to specify an action of solution of a problem. You always, before you go about the solution, it's very important to draw, to put down, to write an hypothesis. That is a behavior anticipation regarding to the established objective. You have to know, you have to have an idea of how this will behave when it ends and how this will characterize the problem. After you have these, go through these 3 moments, you are ready to define a method or a way to go about the solution. This can be exploratory if you're doing an action of familiarization to the problem. This could be descriptive, explanatory, or prescriptive. And each of this method in academia has already written, already established steps that you can go about. If you put yourself to develop the solution throughout the steps that are already there written, all you have to do is appropriate them to your situation. And when you express this to other people have the better chance to understand you and evaluate you. Then after going about this process, you go out performing the steps, collecting data, developing your solution. And you must at the end go back and see what is the performance that you achieved and what was the performance that you had planned, your hypotheses. So doing this gives you argumentation, gives you a moment of learning to understand what you did right and what you did wrong and what you have contributed with. Now, how I go about this? Well, my interest in research is in building information modeling, supporting design and use of houses. During these 32 years of mine in academia, I have done case studies and surveys to understand how things are, experimental research to understand behavior in a controlled manner. Right now, mostly I'm doing theoretical models, so I'm using structuralism for this, and also doing development of solutions, and I'm using, therefore, design science research. This is what I'm going to show you here, how to go about doing design science research, because I think it's the method most appropriate for the teams in Hackathon. Well, looking at building use, the problem I'm going to show you how I went about. In Brazil, every homeowner receives a user manual of his or her apartment or house to help him maintain and use this space. But it's too technical and very textual, so most abandon its use. That's very bad because much effort is put to develop and build this manual, right? And so I have a PhD study developed by Lorena, and the title of the PhD, which I'm going to show you, is Augmented Reality for Building Maintenance. The problem I already started telling you about is the old-fashioned format of user manuals impairs their function. I see that there are teams working with virtual reality going both ways from the virtual reality to the BIM model. This would be a good use to go about this situation. So we developed, wrote many questions about this problem. I'm presenting one of them here. Will augmented reality improve user performance using this manual? So we draw the objective as to evaluate user performance in house repairing using multiple building maintenance instruction manual formats. We started thinking that augmented reality would improve user performance and visualization technologies would impact this performance. We didn't know if for good or for bad, if positive or negative. We chose design science research because we were developing new formats of building maintenance instruction manuals, but we mixed this method with surveys and experimental research. For an analysis, we established that gain was defined as a measure of workload perceived by the user when completing the task. So, and the task was the replacement of a toilet float. Now, here is the outline of a design science research. Always goes about awareness, suggestion, design, implementation, and evaluation. In the stage of awareness, we did 3 systematic literature reviews, of the term augmented reality paired with building information modeling, paired with manuals, and paired with assembly, because we wanted to make sure that we would read everything that had been developed and published in any areas, mechanical engineering, fabrication, education, whatever was out there that associated text with augmented reality, and also instruction of doing something. We also did a survey of building maintenance instruction manual in the whole region of Brazil, in all states of Brazil. We wanted to know how this manual was being delivered to users. Was it structured differently depending on a region of the country? What was its content? What was presented? Did it have similarities? Was it following the standards that Brazil has for this instruction manual? We also did a user opinion study. We talked to apartment owner of a certain building that were already living in this apartment for 2 years, and we interviewed them about how they used, if they ever had used the manual for instructing them in any maintenance situation. We found out that yes, the manual goes to a drawer, but we also found out that they wished or were open to new kinds or new formats of being instructed, of manuals. We also found out that the hydrosanitary system was the system with mostly detailed in this manual, and with most similarities in all regions of Brazil. The manual has warranties, technical assistance, instructions, indication of suppliers, and how to go about operation, use, cleaning, and maintenance of the component associated to that system. So with that in hand, we went to a suggestion. So the systematic literature review gave us insights on technology, what marker to use, what programs to use to develop the augmented reality, and the selection of the task, the replacement of the toilet float. And also we decided to test 2 different visualization equipments, devices, the tablet and the smart glass. And to do this, implement the manual, the traditional printed manual augmented by the augmented reality, but also maybe to abandon the manual and distribute the manual throughout the house, and to see the structure in a one-to-one scale to the component that was being repaired. So we had 3 different situations. We would put the user doing the repair task using the traditional manual, the manual augmented and seen with a tablet or a smart glass, or doing the abandoning the instruction manual and seeing the instruction in a one-to-one scale with tablet or with glasses. Now, in the design phase, we went about structuring our model. So we decided to go to associate the augmentation to the component, use a marker, specific types of marker, associate augmented reality to the market, and the augmented reality would be of 2 kinds. Information, because we have here warranties, technical assistance, suppliers specifications, and the instruction itself animated. Then we went about the implementation. We did the animations, and we developed 4 augmented reality apps, 2 for the marker on the environment, one to be seen with the smart glasses and the other to be seen with a tablet, with these two types of augmented information, or the manual augmented and seen with the tablet or the smart glass. And here, finally, in evaluation, we performed then 5 experiments having 20 different participants per experiment. So we had 100 people participating in our experiments, and we used the NASA TLX protocol, which is a multidimensional assessment process that provides subjective workload index based on 6 factors: mental demand, physical demand, time demand, performance, effort, and frustration. So workload was measured this way. Here you see one of the results, but the most important of them, which shows that the worst performance occurs without the aid of augmented reality. So the participants that use the paper manual to support their maintenance of their task were the ones that said that had felt a worse performance. Well, we found out also that the one-to-one scale eliminates the influence of visualization technology. This can be seen right here. The workload of participants, the workload declared by the participants that use the augmented reality over the environment with tablet or with glasses is 1 percentage of difference. That is no difference in numbers. And the best performance was obtained with the paper printed manual plus augmented reality seen on tablet. Well, we have a new hypothesis here that must be tested throughout other experiments, is that the familiarization that we have right now in our days with cell phones and tablets makes us comfortable in this use. However, we think that when smart glasses comes to our lives just like a tablet, everybody wears one, everybody knows how to manipulate and use it, it will discard this type of use of information. Also, another point in favor of eliminating the printed manual and going all digital, one-to-one scale in a house is IoT. When IoT is present in our lives and all of our equipments are connected to internet, this will really boost and this will be the way to help users with the operation of their environment. Now, if you look at the model that we proposed for the augmentation of the manual, it is capable of to be coupled very well throughout the theoretically throughout the manual itself, and our solution has a positive coupling approach. However, to go in scale, that is, to augment every possible component in the house that needs to be operated and maintained, right? That's a lot of components in a house. Imagine this in a hospital, in a supermarket, in a school. And another problem is that components update with frequency, and also augmented reality technology updates with frequency. Well, this requires a flexible and robust plug-and-play structure. So what is really needed to make this come to users, to every household, is a structure of plug-and-play augmentation of reality to the in relation to the BIM model. Now, Another situation of research now in housing design. I'm going to talk about lack of diversity in large-scale social housing solutions. This is very true in Brazil, and who tackled this problem was Giovanna in her PhD, which she finished in 2019, and the title of the PhD is Design Patterns, BIM, and Machine Learning in the Support of Design Decisions. Now here is the outline of the design science research, and let's start with awareness. Well, awareness will be putting to you the problem that we have in front of us and that we chose to work with, right? Brazil has a large housing deficit, different from Europe, that there's not much space new to construct, not new need for new houses. Brazil has need for new houses. There is a lack of diversity in large-scale social housing solution, and the solution for this problem is large-scale construction, right? So here you have a picture of how diversity is taken about in a simple matter, painting a facade. But people need and should have individualization. Now, computational design and building information modeling, they govern current trends in computer-mediated design and architecture. Computational design promotes solutions for creativity and diversity in design, and BIM increases accuracy of the design. However, computational design and BIM, right now, they are developed separately. They need to dialogue. So our problem is to approximate these two and to tackle the diversity here with this approximation. Now, how did we go about? How did we suggest to make a solution to this problem? Well, to do performance evaluation in architectural design, now we chose to do performance evaluation in architectural design by interpreting, observing, and measuring the integrated behavior of form and function. That's difficult to do, form and function, right? Usually we are looking at either one of them, function or form being stressed by something, but together form and function, it's difficult to tackle. So we chose Design Patterns by Christopher Alexander to qualify social environmental requirements of buildings. We chose to semantically enrich a set of solutions for social housing arising from shape grammar to collectively assess subjective parameters of aesthetic and functional quality. What were the patterns that we chose to work for? Intimacy gradient, which governs the arrangement of internal environments of the house to accommodate fine social interactions. Floor surface is related to comfortable, temperature pleasant, yet resistant floor to use and clean. And south facing outdoors, which positions buildings to the south in external spaces, keeping them in the north side of the site. This is true for us here in Brazil, which is in the south hemisphere. In the United States will be exactly the opposite, in Europe also. Why this? Because people only use spaces outside building if they are sunny. So here we chose 3 design patterns, one that relates the building to the outside, one that thinks about relations in the outside, and the other one that works with information, works with data about materials. Why this one is important? Because we wanted to tackle a problem that that has the vocation, the vocational, this is not the word in English, which has a lot to do with building information modeling, which is I of the information and not just the geometry as these two here are leading with. So here is the steps that Giovanna performed to develop the solution to this suggestion. First, we went about to design patterns that are around 250 and selected 3 of them, the one that I chose shown you before. We had to do a lot of filters to get to these 3. First, we went about, we separated patterns that were about city or about houses, then that were about, that had parameters that could be quantified, and others that could be represented in LOD 200, which is the LOD of BEM in conception. Then we identified the parameters associated to each patterns and translated them into algorithms. Then we implemented these algorithms in visual programming language. And maybe we studied also impacts of these implementation, because there is more than one way to Rome, you know, to Paris. And so, of course, there's more than one way to implement algorithm in a programming language, and that may have impact in the indicator that that parameter, design parameter, puts out. Then we transform the shape grammar 2D schemes into BIM models, and we semantically enrich the BIM models with the design patterns. We extracted the information from the solution set, which gave us a matrix with 101 lines, 101 designs, and lots of columns with the informations that represented the semantic enrichment of the patterns. Now here is also go directly to the evaluation. We put this, we did number crunching with machine learning hierarchical clustering. And here I show you the solution, the clustering, prioritizing degree of intimacy. You can see here that the algorithm was able to divide the 101 solutions that came out of the shape grammar for this layout of social housing into 3 groups, and each of these 3 groups have similar qualification in a degree of intimacy. So here, yes, we can give diversity with the same meaning, and the meaning is the meaning which is very dear to architects when they develop, when they concept. Here is another machine learning clustering where we integrated the 3 design patterns, and we found out that the algorithm did an hierarchy of the design patterns, putting first the relation of the house to the outside, then the floor surface, and for last, the social integration. So this is how the algorithm hierarchized the design patterns. So here again, you have the yellow group, the pink group, the blue, red, and green group of solutions that have the same meaning of integration of these design patterns. So again, we have diversity with similarity in signification. So we implemented collective performance evaluation of a set of design solutions, clustering the integrated behavior of form and function. Our solution can support design decision for diversity. However, if you again want to scale it up, like to apply all the design patterns, which are 250, We don't know if it would be possible. We had a lot of difficulty to find the right algorithm for clustering, and our solution does not include the layout. It only includes the semantic, the information associated to the semantic enrichment of the layout. If the layout could be transformed into a graph, and the number crunching could be done with the graph and the semantic data associated, we think that we could have better results in finding latent patterns. So I'm already getting into the end and going to my close remarks. I have shown you that design science research in architecture, engineering, construction is an academic approach to development. However, movement in the opposite direction is required, and this is what you are doing in this hackathon. Very important, very dear to all of us. If I would have to give another title to my talk, this would be it. Science in architecture, engineering, construction, and development in information technology. Where do they meet? Where one place they meet is here with you guys. Now, the last closing remarks. With great power comes great responsibility. So please think as scientists, listen to them, look for them, work with them. This would make a great contribution to our environment and to the whole community, the whole, everybody in the whole world. So thanks for having the time to listen to me, and I am here to answer your questions.